question. Pav, you have not reminded me. Okay. Hot teapots are placed on the tablecloth or mat to prevent heat from damaging the table. So we can talk about, we can say tablecloth or mats, tablecloths or what? Or mats placed on tablecloths or mats prevent heat from damaging the table. Some of you don't know why those tablecloths are there. I mean, say that's for decoration or what. So the reason is there because when you get your hot kettle and you put it on the table, you may burn up the table. So what they do is that you put it on the tablecloth. The next one, wooden spoons and forks and what I use to stir soup for cooking. Bridget, you are the one who gave us this answer, isn't it?
Yes.
Seems these days you have learned how to cook. Soup when cooking. And Pav gave us this one. So blankets are used for keeping our bodies warm. So you can say blankets, stroke, cloths or clothes are used to keep our bodies warm. Then the next one is woolen clothes are worn when cold to decrease heat loss. So it is the same thing. So I've talked about blankets and clothes. So there it is the same thing. So maybe you can say woolen clothes. The other one was just clothes. Keep us warm during cold days. To prevent heat loss. Okay. Did you know the process of covering a good conductor with a poor conductor is called lagging? So what's lagging? The process of covering a good conductor with a poor conductor to prevent heat loss. Where do you think lagging is found? So let us write the heading here, lagging during. So let us write the heading lagging. Write the heading lagging, and we define what lagging is. Lagging. What's lagging? Lagging is the process of covering a good conductor of heat with a poor conductor to prevent heat what? To prevent heat loss. So examples where lagging is used. Examples where lagging is used. Can you give me examples where lagging is used? examples where lagging is used. Let us discuss. Have you understood lagging? Members, have you understood lagging?
Yes.
So, what are the examples where we have lagging?
Yes.
What are the examples where we have lagging? Before you tell me, before I show you, okay, examples. So we have what? We have pipes. Are we together? Remember?
Yes.
We have pipes.
Yes.
So we have pipes.
Yes.
So you can see that this is a pipe inside. It's a good conductor, but it has been covered with a bad conductor. Are you seeing that? So there are pipes that are being covered with a bad conductor. What else? What else?
Teacher, what if you say why?
Yes?
What if you say the rubber used to cover the wire, the electric wire?
The rubber used to cover the what?
The naked wire. For
So
electric.
you can say wires covered with rubber. That's very good. That's very good. You see these wires that these people of Yak are using. These days they are covered with rubber. Do you know the reason? Do you know the reason?
Yes.
Because
Yes.
they don't want those wires to absorb heat from the sun and they expand and then they contract. Because in the due process, those wires are going to bend and then they are going to break during contraction. So that's why they are covered with rubber. They are covered with rubber. You can say examples of lagging material. Examples of lagging. Whether it's there. That's something else. Okay. So, okay, pipes, we have seen them. There is wood lagging. That's wood lagging. We have seen the wood lagging. So, normally they cover different materials with wood. Okay, the other thing that I can give you is we can say the side walls of a refrigerator, the side walls of a refrigerator. The side walls of a refrigerator. Have you ever seen the side walls of a refrigerator? Are they metallic? Some are metallic, but in between them there is a material that is used for lagging them. So that material does not allow heat to go through. So see lagging again. Z. Pipes, we have talked about pipes. Unique objects, those are the pipes. Okay.
These are also screwdrivers. The
Screw what?
top of it is screwdrivers. The tops of it are covered with plastic and rubber.
Screwdrivers.
Yes.
Which ones? How?
Why? Hold it.
Sean.
Yes, teacher.
Screwdrivers are covered with what?
With plastics.
With plastic.
Yes.
The things where they put the screwdriver. I know what you're talking about. So here there are some examples. Lagging materials wrapped around the pipes. Others are wrapped around. We have also boilers. Boilers. Yes, boilers. So when you go to hotels, some boilers are lagged such that the outside part is covered with with plastic, so that the heat does not escape from the boiler. So they want to keep the food warm. So even you have seen some kind of containers, and these containers have a plastic outside, then inside they are metallic. Haven't you seen them?
We have.
And they keep in food there. So also those containers are lagged. Why are they lagged? Because we want to prevent it. So we can have also lagged. Prevent heat loss. So the other one for the screw, that one for the screw, it has a plastic outline. The reason is that it is that plastic outline that has got the threads, or the threads through which the screw can be made to rotate, and then it is tightly bound into what it is supposed to go in. So I've just forgotten the name of those plastic things that they first put them in the wall. After putting them in the wall, then they get the screws, and they can screw whatever they want on the wall, but using plastics. So they are not used for heat or to prevent heat loss, no, but they are used to screw or to put the screw within the wall or inside the wall. Okay, so those are some of the examples of lagging, right? So that's lagging. Now let us look at this experiment here. And this is the experiment to show that water is a poor conductor of heat. Experiment to show that water is a poor conductor of heat. So that experiment, okay, we have 10 minutes. So with those 10 minutes, there's something that you should know here. I want you to first watch this video, and then you see this experiment anywhere before we write. So go back. Back and back. Oh. Okay, don't get worried. Okay. So I hope you'll be able to hear the volume.
Now we're going to show that water is a poor conductor of heat. What I have here is a Bunsen burner, a retort stand, a boiling tube clamped vertically in it, a basin of ice, some water, and a small piece of wire gauze. I'm going to place an ice cube into the boiling tube.
So he has got pieces of ice there. He has pieces of ice, and he's placing the pieces of ice in a boiling tube. Now, after placing the pieces of ice in a boiling tube, he puts what we call a wire gauze. You can see the wire gauze here, this dark one. This is the wire gauze. Why does he put the wire gauze there? Because ice floats on water. Because ice floats on water, that's why he puts the wire gauze, to make sure that the ice remains at the bottom of the boiling tube. So the ice should remain at the bottom of the boiling tube. How? By placing the wire gauze. Since the wire gauze for it will always sink to the bottom, so it will keep the ice at the bottom. Now the boiling tube is filled with water, and then he slightly bends the boiling tube to a given position, such that the ice is at this position with its wire gauze, and this other side we have water. So he tightens it on a retort stand and brings a Bunsen burner flame and hits the other side of the boiling tube. So it's hitting this other side of the water. Now what we are going to see is this. We are seeing right now that this flame is hitting the water and the water has started boiling. But the ice is still here and it has not melted. So it is in form of ice, but up here the water is boiling. So what does this one mean? It means that water is a poor conductor of what? Water is a poor conductor of heat. That even if water is being heated from this other end, but because it's a poor conductor, heat is not easily transferred to this other side where we have the ice. So the ice will take long to melt. It will take long to melt. So that's the experiment, that the ice will remain in solid form without melting, but above the water will start boiling. Is it okay? Members, is it okay?
Yes.
So that is the experiment that is all about, that water is a poor conductor of heat. So the first thing that we are going to do, we have 5 minutes that are remaining. So I want you to take a snapshot of this. If you have the book, well and good, but you use this and you draw for me that diagram. Have you seen the diagram?
Yes.
So you leave space there.
Yes.
You leave space of about 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, of about 12 lines. So you should draw some big picture. Don't draw cartoons, Draw some big picture and then you can see. And then we write the procedure at the bottom here.
How many lines should we do?
I've said 12. So the first procedure is put ice in a test tube. Put ice cubes in a test tube. Then the second thing is add a metal and say all wire goes to keep the ice cubes at the bottom. Okay. Then add cold water to the test tube. Add cold water to the test tube. So you can come back in the next session and complete the notes. And you have 3 minutes of add cold water in the test tube. Then the next one is heat the top, heat the water at the top of the test tube. Heat the water at the top of the test tube. Okay. So we have finished writing that. Then we write our observation. So there it is a question saying the observation. So I'm leaving you with that part, observation, and also the explanation. Are we together?
Yes.
So you write what you observe and you write for me the explanation. Okay? Are we together? Yes?
Yes.
And you send the answers on my WhatsApp number 0704 779122. So next time when we meet, we shall look at convection. So thank you for being a good class today, very attentive, and all of you have participated actively. So have a good day and be blessed. Dakia, Sean, it's not yet time for lunch. So you first finish my work and send it now. So I look forward to see all of you next week. Have Sean. Where is Kathy? Today I've not seen Kathy. I've not seen Ruth. I've not seen all those people. So you tell them to come and join. Those ones who are watching this YouTube channel should subscribe to our channel and also get more updates. Should also know that these videos are uploaded on the website. So have a good day and bye-bye.